Hello, on this video, we're going to learn to graph e to the x. This is going to be a level 1 question. First of all, we're going to graph the basic function, which is here, which is y equals e to the x. So the only or the easiest way, in my opinion, to actually graph this is by actually plotting in points into the equation and just putting it in the calculator and finding the number that you get for each number. So first, we're going to make a chart with the points, which will have an x and a y. So initially, the first point that we should try is 0, because any number to the power of 0 is always equal to 1. So we write a 0 and a 1. Then in the x value, we would write a 1. And since e is already a given number, which is equal to 2.71 and etc. So if we were to write a 1, we would get a 2.71. Then if we write a 2, we would get 7.38. We could also write more points, but for the sake of the video, to keep it short, we're going to keep it to those 3 points. So then the only thing we have to do is to graph this function. Here on the right, we have this graph. Of course, it's not perfect, but I have the graph open on Desmos. So I'm just going to demonstrate how to graph it, and then I'm going to go into Desmos to show about the domain, range, vertical, and horizontal asymptotes. So first we go to 0 and 1. We plot it in there. Then we go to 1 and 2.7, which would be about here. And we go to 2 and to 7 point, which would be around here. And then the only thing we have to do is to actually join the points. Although this does not look perfect here because I'm doing it in the computer, but here I have it open in Desmos, and here we can actually visualize how the graph actually looks. So now that I'm here in Desmos, I'm going to explain the domain, range, horizontal asymptote, and vertical asymptote. The domain for e to the x is always going to be all real numbers, since in this not only in this one, but in exponential functions, the domain is always real. So we could just go ahead and write domain equals all reals, or we could also write from negative infinity to positive infinity. And then for the range, if we go back to the graph in Desmos, we see that on the left-hand side, where the negative numbers are, the function seems to be touching the x-axis, although it actually never does. It is approaching 0, but it never actually does. So for our range, we can write 0 to infinity. This function will never, depending on the number that you put on x, it doesn't matter, because it will always give you a positive number that's greater than 0. So that's why the range is from 0 to all the way to infinity. And then from horizontal asymptote, it has the same reasoning as well. So as we also see on Desmos, the line seems to be approaching 0, but it actually never touches 0, meaning that that's our horizontal asymptote, which is going to be y equals 0, and our VA, all exponential functions have no vertical asymptote. in Desmos, it doesn't really show it in my opinion. Since the graph is exponential, it goes all the way up, but it doesn't really demonstrate that there is no vertical asymptote. And that's all.